Alright guys, welcome back. The last time when we left off, we were just getting started. I did a little bit of code commentary to explain the logic behind what we're going to be doing. So we just have a little cube and we've got our little car, and we made our car movement script, okay? So before I attach the car movement script, and now we're going to actually get into the code, okay? Now this is going to look a little overwhelming. But I promise you, I'm going to hold your hand and I'm going to walk you through it all, okay? So I've copy pasted the car movement script. I've removed everything that we don't need right now. As you can see, there's a lot of stuff that's commented out, but just stick with me, okay? Don't lose your mind. One thing that I want to say before we begin the code, okay? We do want our car to follow gravity and physics, okay? So in order for that to happen, we're going to add a rigid body onto our car, okay? Now, at the moment, first of all, what I'm going to do is I'm just going to remove the component, okay? And when I play the game, I want you to notice the difference, okay? So here, as you can see, the car is just kind of floating in the air. Now, just by the way, this is the game view. What the camera is seeing, that is what the user will see in the game. And this is the scene view, okay? Now, if you're wondering why the display is so, portrait-wise, it's just because, well, I've got it set to 1016. If I make it free aspect, it becomes a little bit bigger, okay? So it's completely up to you. I'm going to switch back to 1016. Oops, not this one. What was it? Yeah. I'm going to switch back to this one for now. Anyways, so as you can see, the car is not following any gravity. We expect it to fall down, but it doesn't. Okay, so for that to happen, we have to add to the car a rigid body component. Okay, so I'm going to go ahead and I'm going to add this rigid body. And without changing much right now for this, I don't think we need to change anything right now. If I just hit play, you can just see the difference. Now, as you saw, the car was actually falling, through the floor, and it was actually going right through our cube here. Okay, now we obviously do not want it to go right through. So another thing that we can add on to our, another component that we can add on to our taxi is called a rigid body. Okay, so I'm going to go ahead and do that, and I'm going to explain what that is. Okay, let's see what it's saying. It already contains a rigid body. Let's see. Okay, it doesn't seem to be containing a rigid body as far as I'm concerned. What? I'm sorry. I mean a box collider. My God, I'm losing my mind. Sorry about that. You guys are probably thinking this guy's going crazy. All right, so as you can see, a box collider is basically a box, and here's what it does. I'm gonna hit play, and you'll see what it does. Previously, the car was falling down, okay, but now it's not. As you can see, this box is pretty much like a boundary, okay? So it's kind of making our car, so to speak, solid. It is a collider, okay? We use colliders in Unity because they kind of they help us objects interacting with each other. For example, this cube here, you'll see it also has a box collider, okay? So it's like a solid surface pressed up against another solid surface. If I hold both of these, then you can see that you can at the corner of this cube, you can see these green box collider, and if I disable this, you'll see that the car falls through. It's because the car still has a box collider on it. In fact, I moved the box collider off both of them because they were selected. But even if I remove it off one of them, so for example, if I go to the cube here, and if I remove the box collider, it still falls through because the floor is no longer solid. What I'm trying to say is that what a game object looks like is not indicative of whether okay, just because it looks like a taxi you think, oh, it's solid, but we do need to add a box collider onto our game objects, or whatever spirit collider, depending on the shape of the car. Now, as you can see that this box collider is not very well done. For example, if there is a collision, if something hits our car over here in the front, then yeah, it's going to go through. So we need to change the box collider a little bit. So for example, let's see, let's change that back. Okay, maybe we can make it a little bit thinner from the top, maybe a little bit longer, like so, and by the way, in case you're wondering how I'm moving around in the scene view, you can just hold down the right click and you can use WASD keys, and that's how I'm pretty much moving around. So if I look at it from the top and from the side, it seems like the box collider looks pretty good. So I'm going to leave it at that. So yeah, now we have some physics going on, and we have a box collider which prevents our car from going through the floor, and we can finally start looking at the code. Okay, so at the top we have our variables. Okay, I'm going to talk you through why we need these variables. By the way, if you do not write something like private or public by default, Unity will make it private. Okay. All right, so in our car, what we need is, first of all, we need access to the car's rigid body, okay? We need this little component here because we're going to be using this component, and later on we're going to be using this component to also change the direction of the direction and the speed of the car. Now, I said earlier in the last video that we're going to be using the transform, but it turns out that I'm using, I think, a combination of both. Again, it's probably not the best way. For example, using the rigid body is probably not as bad as directly using the transform, but I think I'm using a combination of both. So we'll just see that really quickly. But this is why I need the rigid body. I'm going to be adding the velocity, in the right direction or the left direction or in the forward direction using the rigid body, which is another way that you can move your game objects. Okay. Then we have a couple of Boolean variables. Now, again, you don't necessarily need them right now, but I've just left them in there anyways. So there's a bool game over. By default, the game over is false. There is a bool can jump. So this is just a Boolean variable which tells us if our car can jump or not. For example, if your car is jumping, then you don't want the user to be able to constantly jump up. Otherwise, the car will start floating in the air, and it's going to seem like you're in the Harry Potter movies or something. So this is basically a Boolean variable which is going to allow your car to jump or not, depending on the value of this Boolean variable. And in case some of you are complete beginners to coding, then a Boolean is just a variable which can take two values, which is a true or a false. And depending on the value of the Boolean, we're allowed to run some part of our code logic or other parts of our code logic. Okay, and we'll see that very soon. I have an integer current lane. And I've set it by default to 0 because it starts off in the middle lane, and I've actually documented what I mean by this, okay? So what I'm saying is we saw in our demo in the first video that we have 3 lanes. So we've got the middle lane, the right lane, and the left lane. And we need to have some idea which lane the car is in. So as I said, we're going to be moving right, middle, and left. And if we are on the leftmost lane, then we need to stop the car from going another left because then it goes off the road. So this variable right here is going to help us keep track of which lane it is in. So if at any point in time this current lane is 0, then we will automatically know that it's in the middle lane and that it can move right and left. But for example, if the value of this variable is 1, then we will know that it's in the rightmost lane and that it can move left twice. So to speak, it can move left once and go to the middle lane, and then it can move left again if it needs to go to the leftmost lane. Okay, we have public integer speed, so this is just this is just a value of how fast our car is going to be going. Now I've made this one public, and this is the first public variable you see. Again, this one over here, since I haven't specified it, it is by default private. So public variables are the ones which can be seen in the inspector. What do I mean by the inspector? So for example, if I go on my car, on my taxi, we can add this component that we're working on, even though we haven't made it all the way. If I remove the console, you'll notice that I now have, just like a box collider, just like we added the rigid body, and just like we have a transform, we now have a car movement script. So this acts like a component, okay? That's the beauty of Unity. So basically, these are little components that, imagine, if you will, basically, each one of these being a different function. So this one deals with car movement. This one deals with gravity, so to speak. So that you can build. It's like building blocks, putting them together and having a behavior. So going back here, I look at this public and speed. You notice that as soon as I've made this variable public, it shows up here in the inspector, and I can change it. It's the reason why I made the speed variable public is simply because I want to be able to change the speed, and I don't want to come back here in the inspector all the time if I feel like the speed is too much or too little. So for example, if I remove this public from here, as I said, and if I save my code and if I go back here, this is going to disappear because by default, when I don't specify anything here, it becomes private. So as you can see, it disappears. weird here. We can still change the speed, but we have to come back here in the code every time, and that is inconvenient. So I'm going to change that back, and I'm going to save it again. We have the next variable, which is paused. Again, by default, it's false. It may or may not be required right now, but I just left it in there because you're probably going to have a pause functionality, and this paused variable will tell us whether the game is in its pause state or not. Now you can see I've commented out a lot of things. I'm not going to go through them, but I'll just tell you what's in store. The animator, well, at some point in time I was animating the car. I'm not sure if I'm doing that still, but we'll just leave that it for now. But you would need an animator if you want to animate your car. For example, I was initially animating the car when it's turning right and left. So that's why it was there, but later on I decided to remove it. Then you see some audio clips. You see a jump sound when the car is jumping, collision, move, pickup sound. Again, all the audio comes in a little bit later, so I've commented it out, but I'm just kind of showing you that this is not some Sputnik that I've written, and it's not something that's scary as well. You don't need to look into these things right now, audio clips, audio sources, but just by the name, you can tell what they are there for. You see a swipe. This was a class that I wrote. This has to do with, mobile inputs. So we're going to ignore that for now as well. We're simply going to get our game working with a keyboard, and then later on in the section, we'll get back to swipe. For the countdown timer, countdown is shown. All of this has to do with, when you pause the game and you want to resume it, you don't want to resume it immediately. So it shows a 3, 2, 1 counter. But again, it is not relevant right now. So these are the variables which matter right now. We have a rigid body. This is going to help us, speed up our car and such. This is a game over. This is going to tell us when the game finishes. This tells us can jump, tells us when we can jump, if we can jump. So if you are jumping and you try to jump again, then it will not let you jump. This tells us which lane we are in. This tells us our speed, and this tells us the state of the game if it's paused, much like the game over one. Okay, so those are it for the variables. Okay, I hope everything makes sense. I've removed all the unnecessary ones, and these are all the straightforward, simple ones. Okay, now we're going to start looking at some more code and see how we're going to be using these variables. Okay, so the start function. The start is a Unity default function. Okay, it's a mono behavior function. So whenever you have a class such as car movement script, which is inheriting from mono behavior, you already come with the start and the update function, and there's a couple others such as awake, late update, fixed update, and such. So the start runs before the update. So start and awake functions. There's another function called awake. So these are really good places to get game initializations. So for example, in this case, what we need is we need the rigid body component of our car. Okay, so just by saying private rigid body here, we do not have access to the actual car's rigid body over here, right? We actually need this. So when I go back in my start function, what I can write is I can simply say something like rigid body get component and rigid body. Now, what does this do? It basically gets this rigid body component from the car. Now, here's what this does. The car movement script, when it runs in the start, right, it looks for, when the start runs, the get component rigid body looks for the object onto which this car movement script is attached. Okay, so our car movement script is attached onto the taxi. And then it looks for a rigid body component on the taxi itself. Okay, so it shuffles through all the components, the transforms, box collider, finally comes and finds a rigid body, and it's like, aha, I found you, and it then returns the rigid body component here. Okay, so this get component rigid body line of code returns the rigid body which is attached onto the same object as the car movement script, okay, and it saves it in our variable rigid body. Now we actually have access to the rigid body. Now we can say whatever we want. We can say rigid body.move in order to move the rigid body and change velocity and so on and so forth. Okay. Other things that you want to do in your start, again, they are not important right now, but if you want to get access to the animator, if you're going to be animating, if you're going to be using some swipe control, so that's what I was doing here, and this is basically initializing some ad networks called TapX, but that's not important right now, and you're free to look at it in your free time. So the only thing we need in our start right now is access to the rigid body, and we're good to go. Okay, so let's look at update. Now, let me tell you what the difference between start and update is, okay? Start runs at the start of the game one time, as the word says, and update runs every single frame, okay? So you're not going to put this line of code over here, simply because you only want to get the rigid body one time, and then you know you'll have access to it in the rigid body. Similarly, car movement script, as you can see in our update, we have a move car function, and this is in charge of moving the car, okay? Now you know that we need to move the car every single frame. The car is going to be moving forward, it's going to be moving right, left, jumping, up, down, all of that. You need to be able to do that all the time, not just at the beginning. So if you were to move this function here at start, it would only run one time, and then the car would stop moving. It wouldn't be able to go right and left, and you don't want that. So that's why we have update, okay? Update runs every frame. Um, there are other forms of update as well, such as fixed update, as you can see. I believe there's also late update, if I can type it. Yeah, so there's differences. For example, fixed update runs every, I believe, 20 milliseconds or something like that. I'm not sure, but if there's something that happens infrequently, but still happens frequently enough, you would use maybe fixed update or late update if you want it to happen after update and such. But for now, here's what we're doing. In our update function, we are simply calling a move car function, which is over here, okay? Now, this is the bread and butter of this tutorial, okay? This is what actually causes the car to move, okay? But we're going to get back to this move car function. But for now, just imagine that we have a black box, and this move car function is going to be moving our car somehow, okay? So let's just assume that it works. That's the beauty of computer science and in general coding, and the beauty of functions, really. Because look, I've purposely closed all of these functions, this void, move car, on collision, enter, on trigger, and this void. I've purposely closed them. As you can see, there is actual code here, but I've collapsed it simply to show you that simply making these functions can help you abstract away, and having descriptive names for these functions means that you don't really you know that this function is going to be moving the car, and you don't really care how it moves, but it moves. So if I were to give this to you, you could just plug in Chuck and expect the car to move in the way that it does move. And I'm going to get back to this, obviously. Um, Now, after the move function, we have a couple of functions, the on collision enter and on trigger enter. Okay, now these are Unity functions, and we'll see how we've used them. Okay, in fact, actually, let's just go back to the move car, and we'll go in order then in that case. Okay, so let me just get a sip of coffee and. All right. Okay, so let's see the logic behind how our car is moving. Okay, here's what's going on. The first thing in the move car function that's being called every single frame is at the very beginning, we just check that is the game over or is the game paused. So these two things stand for an or, okay? So we just check, is the game over or is the game paused, okay? If either of these is true, if the game is over or the game is paused, then it will simply return out, okay? Because when the game is over and when the game is paused, we do not want the card to be moving. I mean, you obviously don't want the game to be over and for the user to still be able to move right, left, jump up and down, or for the card to be still moving forward. So return is just like kicking it out. So what's going to happen is as soon as the game finishes, it's still going to keep running the update function, but it's not going to, it's just going to, every time it comes in here and before even executing any of this code, it's just going to be like, it's just like a failsafe. It's just going to snap out of it. So it comes in here, it checks, oh, game over is true. All right, I'm just going to return, and then so on and so forth. It's going to keep looping, but it's never going to really continue on to the rest of the code. But if you notice, we set game over as false, and we set pause as false as well. So in the beginning, when the game begins, it's going to come in here and it's going to check, is the game over? And it's going to return false. And is it paused? And it's also going to be false. So two false is still going to result in a false, and it's going to be able to continue forward. Okay, there's just a bit of Boolean logic. So if you're a little bit confused about these ors and Boolean logic, just drop me a comment and I'll be happy to explain. Or you could just look it on the internet. It's quite simple and straightforward. Okay. Now I've commented out some of this logic here because this logic has to do with the countdown timer. So we're going to ignore that for now because we're not even pausing the game. So if the game is not over and if the game is not paused, we want to move the car forward every single frame. Okay. So how are we going to do that? As I said before, we are going to be using transform.translate. Okay, so it comes in here. And we can simply move the z coordinate of the car forward and it would move it forward, right? That makes sense, right? That is an intuitive way of moving the car forward. If I simply slowly increment the z axis or the z position of our z coordinate of our position, then the car should move forward. Okay, so move the car forward every frame. I'm translating it with a new vector. Like so. Okay, now what does this mean? Okay, so I want the car to move in the z direction. Okay, so a vector is made up of three components, right? We know that x, comma y, comma z. Okay, now there's three directions. There's the x coordinate, the y coordinate, and the z coordinate, or the three axis. I mean, okay, let me just move this direction light because it's irritating me. Okay, so we need the car to move in this blue direction, which is the z coordinate. Okay, so we need the x to be 0, we need the y to be 0, and we need the z to have a certain value, okay? So here's what I've done. I've said transform.translate. The word translate simply means that I want to translate the transform onto, to a different place, okay? So transform.translate simply means translate the transform in such and such direction. Okay, and what is that direction? We give it a new vector 3. Okay, so we make a new vector 3. We say we don't want to move it in the x-axis, so we give it 0. We say we don't want to move it in the y-axis, so we give it 0. And in the z-axis, what we do is we simply give it 1. We don't really need the 1 here, but this is just saying, okay, let's move it one unit in the z-axis times time dot delta time times speed. Okay, so what this is doing is time.delta time causes movement to happen smoothly. Okay, time.delta time is basically the time between frames. It's a very small amount. It's a very small number, and this allows for smooth movement. So whenever you're going to be moving anything in Unity, you're mostly really going to be using time.delta time extensively because it causes a smooth motion. Okay, and we multiply it ultimately by speed. And as you remember, the speed variable over here is public. Okay, so the reason why we do it is because we want to be able to change the speed with which it moves forward directly from the inspector while we're testing the game. We can just come in here and we can play around with the speed value when we run the game. And obviously, if you move it in negative, it's going to start going backwards. And if the more I increase it, the speed is going to increase. You can probably also already think of the fact that as the game progresses and I need to speed up my car, I can just come in here and by code, obviously, change the speed value slowly. And the more I increase it, the faster it's going to go. So that's what we're doing over here, and I hope that that makes sense. We're simply translating the car in the forward z direction. We're making a new vector, and we are simply making it go forward in the z direction by speed units. And by default, we've set it to 50, but that we can change that upon further testing. Okay, so we've got the forward movement of the car, and I think we're doing quite badly on the time. So I'm going to stop here, but assuming that you followed me along so far, I'm going to show you what the result looks like. Okay, let's just pause here because I've already gone way over time. But if you followed me and if you followed everything so far, then this is what the results should look like. You come over here on your taxi, and if you add the car movement script, and let's move the speed down to a very small number because otherwise it's going to fly off our screen right now. And I want to make it 0.5, but for some reason, Oh yeah, okay, because we used it as an integer. If you remember, we said that speed would be an integer. So I'm just gonna make it 1. And if I run the game now, then we expect that the car should simply move forward. Okay, so I'm just gonna hit play, and it should start moving forward very slowly. And sure enough, the car is moving. Oh, there it goes. Okay, so the point that I was trying to make is if I just move it back a little bit, then you'll notice, I want you to notice the Z transform as I hit the play button. That's the one that's going to start changing. Of course, it falls under gravity, and notice how its Z is changing. Yes, the X and Y are changing, and obviously now that they're falling, but for the most part, it's flat, and they're not going to be changing very much. They're just changing because of the collisions between the floor and the car. But that's the Z-axis is the one that needs to be changing. And it seems like it's doing its job. So I'm going to cut off this video here, and coming back in the next video, I'm going to be talking about moving the car right, moving the car left, as well as jumping the car, okay? So I'll see you soon.